Alright, in this video we're going to go over the last three methods to solve a quadratic equation, and that is going to include the square root method, the completing the square method geometrically. There's also a way of doing the completing the square method algebraically, but we're not going to cover that in this video. And then lastly, the quadratic formula. So first off, starting with the square root method. This is used for equations that have just the presence of the variable x with a square. And it says that if x squared is equal to p, where p is a positive 0 or equal to 0, a positive number or equal to 0, then x is either equal to the square root of p or equal to the negative square root of p. Previously in our lecture notes we talked about x squared equals 9. Well, when we square root this, we get two answers. X could equal 3 or x could equal negative 3, because both of these numbers, 3 and negative 3, when you square them, gives you an answer of 9. So that's what the basis of the square root method is. So a few short examples from this one. X squared equals 5. We're going to square root both sides, and we'll just say that the answer is either equal to the square root of 5 or x is equal to negative square root of 5. And that is our answers. Now, if the radical can be simplified, it has to be simplified. So as an example, if we had square root of 20, 20 can be factored down into 2 times 10, 10 can be factored down into 2 times 5, and since the number 2 appears twice, a 2 would get brought to the outside, and since there's only a single 5, a 5 would stay on the inside. So if your answer would be square root of 20, we would actually simplify it down to 2 radical 5. Now here's a more complex example over here on the right hand side. But in order to get x by itself, we have to move the 3, the negative 2, the squared, the 6. And in doing that, though, we're just going to do order of operations backwards. So we're going to minus the 6 over. We're going to get 3 times x minus 2 squared is equal to 27. We're then going to divide by 3, which gives us the quantity x minus 2 squared is equal to 9. And then to get rid of the square, we're going to square root. Now when we square root, that means x minus 2 could equal 3, or x minus 2 could equal negative 3. So now we have two equations to solve. So we add 2 on this one, and we get that x could equal 5. We add 2 on the second one, and we get that x could equal negative 1. So two solutions to our quadratic equation. Now a kind of a intricate way of solving a quadratic is through what's called completing the square. And like I said, there's an algebraic method, but we're not going to go over it just for sake of time. But we will go over the geometric method because it is a very nice way of looking at quadratics. This technique is where we take this quadratic expression and we write it using a geometrical square shape. And we're always going to dissect our squares as such. So in doing this, what we have drawn is we have a square, a smaller square, and then two symmetrical rectangles. X squared always goes in this top left square. And in order to make a square that has an x squared, an area of x squared, the side lengths would have to be an x by x squared. Therefore, x times x gives us x squared. Now these two rectangles, here and here, have to combine to make a total of 6x. Therefore, each of them would have to be 3x. Now, if this rectangle has an area of 3x, and we know that this side length here is x, then the side length up here would have to be 3, making this entire side of the square x plus 3. And then since this is 3x down here, and this side is x, this dimension here would also have to be 3, making this side of the square x plus 3. And then down here in this bottom corner, this would be a square whose dimensions is 3 by 3, which has an area of 9. Now our quadratic does not end in a 9, it ends in an 8. But if we add 1 to that, 8 plus 1 makes 9. But whatever we do to one side of the equation, we have to do to the other side of the equation. So we get x squared plus 6x plus 9 is equal to 1. And the convenience of this is x squared plus 6x plus 9, that's all of these quantities combined. And when we combine all these equalities, combine all of these quantities, we create a geometrical shape that's a square where each side is x plus 3 and x plus 3. So this quantity, x squared plus 6x plus 9, can be replaced with x plus 3 squared, because this is the x plus 3 geometrical shape is a square. And then that's equal to 1. So then from here we would square root both sides, which would give us x plus 3 is either equal to 1 or x plus 3 is equal to negative 1. Minus 3 on both gives us x could equal negative 2, or x could equal negative 4. Now in all of these, we're going to do the same process. We're going to get it set equal to 0. So we're going to add this 4 over, and then we're going to run through this exact same process. Now this method is convenient if we start with x squared plus bx, where b is an even number. Okay, so if b is an odd number, this method's not as convenient or quick. But, so here we go. We're going to draw a square, and we're going to dissect it as such. And this first square up here is always going to be the x squared. That gives us x squared here, which means that the side lengths are x and x. These two rectangles combined have to make a total of 8x, which would imply that each of them have to be 4x. And then since this side length over here is x, this dimension up here would be 4, making this entire side of the square x plus 4. And then same down here, since this is x, this right here would have to be 4, making this whole side of the square x plus 4. So we've now just created what's called the x plus 4 squared. Now since this is 4 and 4, this bottom square has an area of 16. We do not have a 16 here, we have a 4. But we can make it 16 by adding 12 to both sides. So we get x squared plus 8x plus 16 is equal to 12. And the reason we do that is this quantity is this geometrical shape, the x plus 4 square. So we get x plus 4 squared is equal to 12. And then we're going to square root, which means that x plus 4 could equal the square root of 12, or x plus 4 could equal the negative square root of 12. That means x plus 4 is either equal to 2 radical 3, or x plus 4 is equal to negative 2 radical 3. And then both of these we're going to minus 4 over. Now the negative 4 can't be combined with 2 radical 3 or negative 2 radical 3 because they have a radical attached. So the answers are just negative 4 plus 2 radical 3 and negative 4 minus 2 radical 3. Alright, and so that's the completing the square method, and once again, that method is always convenient when you're starting with x squared and b, the value in the middle, is an even number. So that's the next method of solving a quadratic. And then the last method, which is usually probably the most popular, is the quadratic formula. And it just says if you give me a quadratic equation in standard form, ax squared plus bx plus c is equal to 0, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, and this formula is dependent upon it being set equal to 0. We went over the proof of this formula in class. I'm not going to do that in this video, but we're just going to go over the applications of it. So first off, to get it set equal to 0, we're going to minus the 7 over, and we're going to add the 2x, giving us 2x squared minus 3x plus 1 equals 0. Our a is 2, our b is negative 3, and our c is 1. So now we're just going to fill this formula in. Negative b, negative 3, plus or minus square root b squared minus 4 times a, 2, times c, 1, all over 2 times a, 2. So we get x is 3 plus or minus the square root. Negative 3 squared is 9, minus 4 times 2 is 8, all over 2 times 2 is 4. So we get 3 plus or minus the square root of 1 over 4. This gives us 3 plus or minus, well, the square root of 1 is 1 over 4. And then this would get split up into two equations, 3 plus 1 over 4, or 3 minus 1 over 4. 3 plus 1 over 4 gives us 4 over 4, which is 1. 3 minus 1 over 4 gives us 2 over 4, which reduces down to 1/2. So our two answers are 1 and 1/2. Now applying the same concept over here, we would first off minus the 30 over. A is 1, B is negative 4, C is negative 30, and then we just fill it in. So negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 30 all over 2 times 1. So that gives us 4 plus or minus the square root of 16 plus 120 over 2. That's 4 plus or minus the square root of 136 over 2. 136 breaks down into 2 and 68. 68 breaks down into 2 and 34. 34 breaks down into 2 and 17. So we have the number 2 showing up twice. So a 2 gets brought outside the radical. A 2 and 17 do not appear twice, so that 2 and 17 multiplied back together makes 34. And then all of your rational numbers are any number that's outside of the radical. So 4, 2, and 2, if they can be simplified, they have to be. 4, 2, and 2 are all divisible by 2. So we're going to reduce it. 4 divided by 2 is 2. 2 divided by 2 is 1. And the 2 on the bottom divided by itself is 1. So it would simplify to 2 plus or minus radical 34. Once again, we do not divide radical 34 by 2 because it's an irrational number, whereas 2 is a rational number. So that's the quadratic formula. And then lastly, if you notice that b squared minus 4ac, the quantity that's inside of the square root, if it's less than 0, there is no real solution. The reason being, the square root of a negative is defined to be a imaginary number. So if you run across a problem where the value inside of the radical is a square root of a negative, then there is considered to be no real solution. So we can run through this example just real quick. This would be negative 4 plus or minus the square root negative 4 squared minus 4 times 1 times 6 all over 2 times 1. This is 4 plus or minus the square root of 16 minus 24 all over 2. That's 4 plus or minus the square root of negative 8 over 2. There's no need to go any further. Since we have the square root of a negative, we just say that this problem has no real solution. Alright, and that finishes up all the methods for solving a quadratic. If you have any questions, feel free to email me. The problems that you should be able to do on the homework assignment is problems 8, 9, 10, 11, 12, and 13 based on this video. Thanks. I'll talk to you later.